Now we have our outputs from the decade counter coming out as binary coded decimal. You can see here it's counting to 9 and resetting. Hey, it works. And I took all of them out. Let's make a decade to binary converter using this core rope memory, or rope core memory, I should say. So I have a detailed video on how core rope memory works and how to implement it. But basically, to summarize, the way it works is that you have ferrite cores set up as with enamel-coated copper wires with 20 windings around them, and if you pass an AC signal through them, it induces an electrical signal in the copper wire, which can be sensed with the op amps. And based on the AC signal going into or out of the copper cores, that corresponds to the end signal being on or off. Each AC signal wire is basically coming from an individual transistor, which is turned on or off by a control signal. And in this case, it's a CD4017 counter. And that controls whether the signal goes out, and that's the address line. But now to make a binary encoder, basically you have the first output going through the first ring to give us a binary 1. The output of the second output goes through the second ring to give us a binary 1, 0. The third output goes through the first two rings, give us a binary 1, 1. The fourth output goes through the third ring, which gives us a binary 1, 0, 0. The fifth output goes through the first and third rings, gives us a binary 101. Binary 6 is 110. Binary 7 is 111. And the binary 8 is 1000. And that's coming from the 8th output or 8th address line. So in this way, this is the schematic using only 4 cores to make an 8-bit binary counter. So I'm going to use this one as the least significant bit. And remember, only the 10. So this is the least significant bit. This is going to be the most significant bit. So let's give this a shot. So in order to weave the memory, or to hardwire the memory in place, we have to weave a tangled web here and manually hardwire all of the data in place according to the schematic and what I'm calling the most significant bit and the least significant bit. And now we have the ends of the rope terminated at ground, and you can see the last 4 cores on the left are the 4 that we used in order to make the binary encoder. So now I have the core rope memory inputs attached to this ribbon cable. I'm going to test the various outputs with the lights. Here's 1, 2, 3, 4, 5, 6, 7, and 8. It works. Okay, now we have this core rope memory. Just the last 4 bits of it wired up as a 0 to 8 binary to decade converter. So I have the signal coming in from the CD4017 decade counter, and all the outputs are slowly going into the inputs of the core rope memory circuit, and in order from 1 to, since 0 it basically doesn't activate any of them, 1 to 8. And here's the binary counter. The least significant bit is on the left, and it's counting in binary now, even though the input signal is coming from decade. So it's a decade to binary counter, all with core rope memory. Much easier. 0, 1, 2, 3, 4, 5, 6, 7, 8, 0. And it's resetting on the 9th. But since I only have 8 address lines here, I can only do 1 through 8 here. And 0 is 0. And that's how you do core rope memory as decade to binary conversion. So now we have it counting from 0 to 8, but let's see if we can make it count all the way to 9 and make it a true BCD encoder. So since we only have 8 inputs, 8 address lines, but we want to count to 9, we're going to have to use the diode trick and basically create diode OR gates. So the 9th output of the CD4017, I have the first output and the last output, which creates a binary 9. If both are activated at the same time by using this OR gate, then a 9 will flash. Now I incorporated 9 with these 2 diodes from the 9th output. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is BCD. It counts from 0 to 10 essentially. So it's a binary coded decimal. So decade to BCD now. Could do a lot with this core rope memory. And the only extra components required to make it go to 9 are these 4 diodes. Pretty good. Now with a little extra logic, and no extra components other than another CD4017, I have this counting to 16. All with the core rope memory and a cascaded CD4017 counter. So this is decade to 4-bit binary conversion. So the realm of possibilities with core rope memory is endless, and there's a lot of fun, neat things you could do with it. Here's the final schematic. Thank you again for watching.